I'm part of the Science Education Initiative group in MCDB, and what I'm going to tell you about today is some work we've been doing trying to use clickers to both measure learning in the classroom and also to try to get at retention, not of facts, but of concepts. So a lot of work has been done on retention, how testing influences retention, different kinds of protocols that can affect retention, but a lot of that retention work is done with recall of facts and isn't maybe as useful to us if we're thinking about conceptual understanding of biology. So we're trying to look at ways to measure it in the classroom using clickers. And the work I'm going to talk about today is primarily the work of myself and Michelle Smith, one of the STFs in our department, but I want to acknowledge especially Caleb, who has been working with us all year on various projects and who has given me a lot of good comments on this work, as well as Jashi, the other STF, and Sarah Wise, a brand new STF, and of course Phil. And I forgot my advancer and a pointer, so I'm just gonna like wave my arms around unless somebody has a pointer. Okay, thanks, Leilon.
Who's your advancer? No, I'm just kidding.
Yeah, so anyway, what I want to start with is work that you guys may have already heard about because it's been published already, but I thought it doesn't really make sense to talk about the other work until I talk about this work. So this, we set out last year or a year or two ago to try to prove the value of peer discussion following clicker questions in the classroom. And this was because we were all using a lot of clicker questions, and we really like using peer discussion after the clicker questions, but there wasn't a lot of evidence that students were actually really learning from the peer discussion. It's pretty clear that students learn from using clicker questions when they talk to each other and they vote again. They usually vote higher percent correct than when they vote individually, and that had already been shown by Eric Mazur in physics. Yes.
Do they see the answers from the whole students before they
No,
vote the
they
second
don't.
time?
They don't. So let me start with the work from Eric Mazur in physics. He showed that it was very clear that when you ask students a question individually, if the votes were split, that if you let them talk to each other and re-vote without necessarily seeing this distribution, or in this case it doesn't matter very much because they're all pretty equal, that students would converge on the right answer without the involvement of an instructor. So this had already been shown. We'd seen the same phenomenon in our own courses, but what we wanted to know was, are students just voting what their knowledgeable neighbor is telling them are the right answers, or are the students actually learning from the discussion? And we thought the way to do that would be to use this protocol of asking a single question, letting the students discuss the answer, their ideas, vote again, and then follow it with another question that was on the same concept. We call it an isomorphic question. So it's a new question, basically the same idea, testing the same concept. If the students understand the new idea, they should be able to then also vote correctly on the next question individually. So that was basically what we set out to look at. And we did this with the help of Tintin Su in her genetics course, which is a large course taken by MCDB majors primarily. And this was the design. So to answer your question, students answer a clicker question individually. Sorry.
Oh.
Let me close my email. Shall I do that? Yes. Very good. All right. Luckily that was not personal. Okay. Because you know I have a very exciting personal life. So students
Could you put that back up again? So
students answer a clicker question individually. They talk to their neighbors. They do not see the results of what anybody else voted. And then they answer a new question. So here is their performance on a bunch of sets of isomorphic questions across the whole semester. Their initial performance averaged out to about 50% correct. After discussion, jumped up quite a bit. And then, without, again, seeing the answers of their peers or hearing anything from an instructor, they got another question, Q2, and then all the histograms are displayed and the answers are discussed, so that there can be some closure for the students. And what you can see is that, in fact, their performance does continue to go up on the second question. this suggests that the students are in fact learning something during the discussion. The instructor said nothing, so they're presumably figuring stuff out on their own or listening to their neighbors and learning from what their neighbors have to say. There are two actual possibilities for what's going on. One is that it's a totally transmissionist type of approach where the knowledgeable students are saying, this is the answer, this is how you need to think about it, so do it this way. The other is that the students don't, maybe many of them don't know the right answer, and they're simply talking about it together and figuring out what the right answer is, which is more of a constructivist approach to how they might be learning. And we wanted to know whether it was one or the other, because it would be really cool if they were using the constructivist approach to get to the right answer by basically figuring it out on their own, as opposed to just listening to somebody else who was dictating the answer to them. So what we did was we split the questions into categories based on the initial performance. So we didn't divide them out into easy, medium, and difficult questions ahead of time, because our perception of what's hard and their perception of what's hard is not necessarily at all overlapping. So we just asked these questions, and then later, when we were looking back at the data, we thought, well, there are a group of questions where people did fairly well on the first question, and so 70% or so or higher. So we labeled those easy questions. Then there were the medium questions where the average performance was around 50%, and the difficult ones where the average performance was really low. There really very few people understood the correct answer at the first benchmark of Q1. And what we saw from this is that there are good trends in all of these categories. So for the easy questions, there is improvement from, even though it's easy, they still get better. For the medium, this is not a significant difference here, but they do at least maintain the knowledge they discussed with their peers. And for the difficult questions, they make a really big gain. So although they don't get as high as they do over here, the gain from Q1 to Q2 is significantly larger. So even when you've got a group of students who statistically, very likely that there were many groups around the room where nobody knew the correct answer, they were still able to get to the correct answer. So this category here in particular suggests that at least some of the time, the students are using a constructivist approach to generate the right ideas that allow them to answer the question correctly. Please feel free to interrupt me if you have questions. Doug, it looked like you might have a
You're
question.
going fast for me.
No?
I do.
Okay.
You're going fast for me. So it takes me a
Well, this
while.
is all like old stuff, so I was
Oh, it's
kind of
old stuff,
speeding
like
through
that.
it, thinking that some of you may have already seen it
Sorry.
before. Am I wrong? Michelle never presented this last year, did she?
We read
I
the
think so.
papers.
Okay.
I was absent.
Okay.
We read
That's
the
why I'm going so
papers.
fast,
It's
because
okay.
I didn't want to bore
Go
you.
ahead and
So-
blast
No,
through.
please.
I was just wondering how you made the inference that those data, just once again, can you
Yeah.
remind
That
me
this
why those data
demonstrates-
imply
yeah.
construction?
So what we did was we asked the students on average, how many people do you talk with when you're having your discussions, and they said about 3. And then we did a statistical analysis, which suggested, I didn't do the stats, so search me. I can tell you basically the idea, which is that if only 15% of the students got the answer correct, then the distribution of those students around the classroom would suggest that if the students were working in groups of 3, there had to be many groups where nobody knew the correct answer. Certainly there were some groups where somebody knew the correct answer, since 15% on average had the correct answer. But many groups must have consisted of 3 or 4 or 2 people who did not answer correctly. So statistically speaking, that suggests that in those many groups, I can't remember the exact, numbers,
Yeah,
but
that was
in those
generated.
groups must have created knowledge
Nice.
on their own.
Got it.
Yeah.